So 6.4 homework, we are doing partial fraction decomposition. And the first thing to do with all of these problems is to factor the denominator. So we'll start with number 1 here. And we need to factor that denominator. So leave the numerator as is. Two numbers that multiply to be 6 and add up to be 5 would be positive 3 and positive 2. So this does rely a lot on your factoring skills from Algebra 2. If you're not super great at factoring, then make sure that you practice these, practice the factoring, use whatever method of sort of factoring that worked best for you, split the middle, AC factoring, whatever you are most comfortable with. What we need to do though is get it into two factors like this. Since we have these two factors, we're going to rewrite this as a split fraction. So we will have a over the first factor, x plus 3, plus b over the second factor, x plus 2. Then what we need to do is set up our system of equations, and the way we do that is by multiplying each part of the fraction by what was missing. So the a fraction is missing x plus 2 in the denominator, so we're going to have a x plus 2. And then the b fraction was missing the x plus 3 in the denominator, so we'll have b x plus 3. And then that is equal to the original numerator, which was x plus 1. So from here, what we want to do is we want to use the two zeros from this denominator to solve this system of equations. There are other ways to do it, but this is the fastest and most effective way that I've found. If you looked in the book, they do have a little bit different sort of method of doing it. I would just suggest doing it this way. So we plug in -2, so the first zero is -2. We plug it in for all the x's. So we're going to get a 0 for the a value. B times 1 equals -1. So that means that b is equal to -1. Then we're going to do the same thing for the other factor. So we're going to be plugging in -3. And when we do that, the b quantity should be a 0 now. So we will have a times -1, b times 0 equals -2, which means -a is equal to -2, or a is equal to 2. So we now have our two a and b values. We're ready to go back and rewrite this fraction as a decomposed sum of two smaller fractions. So our a value is 2, so 2 goes over x plus 3, and the b value is -1, and that goes over the x plus 2. It doesn't matter, again, what factor you had written first. So your answer might be in the opposite order. It might be -1 over x plus 2 plus 2 over x plus 3. As long as the 2 is over the x plus 3 factor and the -1 is over the x plus 2 factor, it's the same thing. So it doesn't actually matter which order you end up factoring it down to be. You should get the same two answers out, and they should go over the same fractions in whatever order they come out in. So for the next one, number 3, this should be the same idea where there's nothing special going on. The bottom should factor pretty cleanly, and then we will do the same process as we just did. Okay, so again, we want to factor the denominator. So I need two numbers that multiply to be 12 and add up to be 7. So that's pretty straightforward. It should be 4 and 3. So there we go. Those are the factorings, and then we're going to decompose this into a over that first factor, x plus 4, plus b over the second factor, x plus 3. Now we're ready to start writing our system. So the a factor, or the a fraction rather, is missing the x plus 3. So we're going to have a, x plus 3, and then the b is missing the x plus 4. We set that equal to the original numerator, x plus 13. So the first value we're going to plug in is x equals negative 3. So that'll make the a 0 plus b times positive 1 equals 10. So that means b is equal to 10. There's our first decomposed numerator. And then we're going to do the same process again. This time though, we're going to plug in negative 4 to make the b quantity 0 and get the a number. So we get negative a, I'll do it the same way I've done everything else, a negative 1 plus b times 0 equals, that is 9. So we have negative a equals 9, or a equals negative 9. Okay, and now we go and write these back over the appropriate denominators. So the a quantity is negative 9, and that's going over the x plus 4. The b quantity is 10, and that's going over the x plus 3. So there we go. The next one I think is 7. So 7 is, they tell us here, find the PFD of each improper rational expression. So the improper rational expression, these are the ones where we need to do long division first before we can do the PFD. Okay, so we just need to remember what we do for long division. So we have our numerator 3x squared plus x minus 4, and the x squared minus 2x. For us, it's always just going to be a constant that works through, so you don't need to worry about these first two columns. They should always be blank for the ones we're doing. So it really is just whatever we need to get down here. So the first term to be exactly what's on the inside, it's different by 3, so it should be a constant. So when we multiply that, it is 3x squared minus 6x. Remember, when we're doing the long division, we need to subtract. That way we get a 0 for that first column. So we have x minus negative 6. So really it's x plus 6, so we get 7x minus 4. So that remainder is what we want to use, because this fraction is actually 3 plus that 7x minus 4 all over x squared minus 2x. So this is the fraction we want to decompose, the 7x minus 4 part. The denominator here is going to factor to be x minus 2. So we get a over x plus b over x minus 2. So the a factor is missing, or fraction, excuse me, is missing the x minus 2. B is missing x, and we set that equal to the new numerator we found, which is 7x minus 4. So the first 0 we're going to plug in is positive 2. All right, so we get a times 0 plus b times 2 equals 14 minus 4. So 2b is equal to 10, b is equal to 5. Now we do the same thing, but we use the other 0, which is just 0. So we have a 0 minus 2 plus b times 0 equals 7 times 0 minus 4. So we get a times negative 2 plus b times 0 equals negative 4. So negative 2a equals negative 4, or a equals positive 2. Okay, so now we're ready to rewrite. We don't want to lose track of that 3. That 3 needs to show up on our answer, so it's still 3 plus the a value, which was 2, over x plus the b value, which was 5, over x minus 2. Very important we have that 3 out front. We can't just have the 2x and the 5. Okay, and then the last one we had was 17. So 17 says, find the PFD of each rational expression with a repeated factor in the denominator. So we have a repeated factor, and the work we need to do is just a little bit different for the repeated factors. So they gave us 17x plus 256, which is a big number there in the numerator, all over x cubed minus 16x squared plus 64x. Okay, so we have a cube in the denominator as well here, so we should start by factoring an x out of everything. So the first step will be to pull that x in the bottom. So x squared minus 16x plus 64. Okay, so at this point we need two numbers that multiply to be 64 and add up to be negative 16. The kind of giveaway here is that it's a repeated factor in the denominator, so what we should see is that denominator factors to be the same thing twice. So x minus 8, x minus 8. Okay, so that's what they're talking about, again, when they say a repeated linear factor in the denominator. We have x minus 8 twice. So we need to do a little something special again to account for that. So we start with a over x, which is normal, plus b over the first factor, which is 8, or x minus 8. But then the third factor for c, we need to do x minus 8 quantity squared. And again, that only happens when we have a repeated linear factor in the denominator. So it has a multiplicity of 2. So we had to include it as a squared value. If the reasoning doesn't really make sense, that's okay. Just remember, if it is a repeated factor, the second one is squared. So for this one, we're going to have a little bit more of a system to work with than the previous problems, but we doing the same stuff. So the a fraction is missing 8, or sorry, x minus 8. Keep saying it the wrong way. X minus 8 squared. The b fraction is missing an x and another of those x minus 8s. And then the c fraction is just missing an x. And that is equal to 17x plus 256. Okay, so once we've got that set up, it's the same process we've done for the first three problems. We're going to start picking the zeros and plugging them in. So the first one to do is 8, so x equals 8. So we've got a 8 minus 8 squared plus b 8 minus 8 plus c times 8 equals 17 times 8 plus 256. So for A, we're going to get a 0. B, it's B8, but then it's also a 0, so that one should be 0. And for C, it's just C8. On the other side, we should end up with 392. So we have 8c is equal to 392. Big number, but that's okay. C is equal to 49. Okay, so we're going to do the process again. This time we are going to plug in 0. So A, 0 minus 8 squared, plus B, 0, x minus 8, oops, sorry, 0 minus 8, plus C times 0. 17, 0, 256. Okay, so for the A part, we're going to get negative 8 squared. B is going to be 0. C is going to be 0. And on the other side, we get 256. So A times negative 8 squared, that is positive 64. So we get 64A equals 256. Or A is equal to 4. Okay, so here's where it gets a little bit slightly different again. Since we've now used both of the zeros, the distinct zeros, we can't do 8 again. If we do 8 again, we're going to get zeros again everywhere but C, so we just get another answer for C, which we've already found. We need B. So we don't plug in a 0 to get B. What we have to do for B is we need to take the two answers we've already found, A and C. We need to pick an arbitrary value for X that's not one of the numbers we've already used, and then put all of that together to find B. So I always suggest picking the arbitrary X value of 1. It's the easiest non-zero, and as long as we've not used it already in the problem, that's a great one to pick. If you haven't used 0 in the problem, that's the one that you should pick. If you use both of those, just kind of work around zeros, ones, twos. Keep it small numbers as best as you can for the X. So we're plugging in X is equal to 1, A is equal to 4, and C is equal to 49. We're plugging all three of those values into sort of this original equation up here. So I'm going to copy and paste that down here. Okay, so the A value again we said was 4. We're picking an arbitrary X. I picked 1. The B value is what we're trying to solve for, so that's going to stay as an unknown. The arbitrary X value we picked was 1. Again, 1 minus 8 plus C. We know C is 49. That arbitrary X is 1 equals 17. That arbitrary X is 1 plus 256. So we've substituted those A, C, and X values, and that's just what we're going to end up with. So we will have 4 times negative 7 squared plus B times 1 times negative 7. So it's really just times negative 7 plus 49 equals 17 plus 256. I probably could have went ahead and combined those, but whatever. Okay, so we keep working down. 4, 7 squared, that is positive 49. So we have 4 times 49 plus negative 7b plus 49 equals 273. So 4 times 49 plus 49 is going to be 245 minus 7b is equal to 273. So we take 273 and we subtract 245 and we end up with 28, which is great because that is divisible by 7. So we end up with B as negative 4. And that's great because all of these numbers that we've got for this homework are whole numbers. The ones that they give us, the problems that they show here in the book, almost all of them are. I think there's only one of these in this sort of problem set from this page that had some decimals or fractions in it. Everything else was pretty much a whole number. So they're not going to give us too many fractions, too many decimals in here. They can, but they are pretty easy on us in not giving us too many of them to do. So the last step again is to go back and rewrite this. So our fraction, I'm going to do it right here. A was 4, so 4 over x. B was negative 4, so plus negative 4 over the single factor, x minus 8, plus that big one we got 49 over the repeated factor, x minus 8 quantity squared. Okay, and that should do it for the homework. Again, a lot of this is having good factor skills and then very, very basic algebra, just plugging in zeros. Nothing too crazy in terms of solving a system. We just put this in this chapter because you can solve these systems. You can use matrices to solve them, but plugging in the zeros the way that I've shown it here in the notes and homework, I think is a much, much easier way to go about these problems.